Hello everyone. We have discussed analytical treatment for triangle law of vector addition, where we have seen that how the length or the magnitude of the resultant vector can be determined, as well as how its direction can be specified. Now we are going to do the same thing, that is, we are going to analyze that parallelogram law of vector addition, and we are actually going to find the magnitude of the resultant as well as its direction also. So let us see how it is done. Go through the video very carefully and see to that everything is clear to you. So here we are going to start the analytical treatment of parallelogram law of vector addition, where we will be discussing the magnitude and the direction of the resultant vector. The two vectors which are given to us is vector A and vector B, and we are going to find the magnitude and direction of the resultant vector R. So let us see how it is done. Look here, we are considering parallelogram law of vector addition, where vector A and this vector B, they are considered to be the two adjacent sides of a parallelogram, such that they start from the same initial point O. As we have already discussed in the parallelogram law of vector addition, then the resultant is given by the diagonal of the parallelogram passing through the co-initial point O. This resultant R is given by vector A plus vector B, which simply represents that this vector, which is R, is the resultant of the two vectors, vector A and vector B. But from this vector R is equal to vector A plus vector B, we don't get the actual length of vector R or the magnitude of vector R, and we also don't get the direction. So we need to find both the magnitude as well as direction of the resultant. So for this, what we do is, from the point S, we drop a perpendicular and which meets OP, which is produced at the point N. And at the point N, you can see the two lines SN and PN are making an angle of 90 degrees with each other. So we have a right angle triangle SON. This is the right angle triangle that we are having. Now the angle between the two vectors, that is vector A and vector B, is given by theta here. You should understand this very clearly. This angle is the angle between vector A and vector B, and vector B is represented by OQ, and same PS also represent the same vector B because same length and same direction. So you can see here the angle here also is the angle between vector A and vector B, which is theta. Same angle, whatever is here, the same angle we are having here, because both theta here represents the angle between the vector A and the vector B. Okay. Now see, the angle, we have already mentioned what is theta here. Then the length of the vector A is given by A, that is OP is equal to A, and in the same way the length of the vector B, that is PS or OQ, they are the length of vector B, which is given by B. So I hope this is very clear to you. So if this is clear, then what we will do is, we will consider the triangle SNP. It is a right angle triangle, so we will be using the relation for cosine and sine angles, like sine theta. Theta is the angle which you see here. So sine theta will be given by SN by PS, that is perpendicular by hypotenuse. So the value of SN will be given by PS sine theta, and PS is B. So SN, this length SN will be given by B sine theta. Same way, cos theta can be written as PN upon PS. So the value of PN can be given by PS cos theta. Okay, and PS cos theta is B, the length is B, so it is B cos theta. So Sn is b sine theta and Pn is b cos theta. So we have these two relations. Now we will consider the right angle triangle SON and or we can say ONS, which is written here, the right angle triangle SON or ONS, same thing. So we'll use the Pythagoras theorem where hypotenuse square is equal to the sum of the side square. So hypotenuse square is OS square is equal to ON square plus NS square, where the value of ON is OP plus PN. So we write OP plus PN whole square is plus SN square. Now we will expand it. OP is A and Pn we have already just now calculated in the previous slide. It is B cos theta. So A plus B cos theta whole square plus this Sn is B sin theta. So B sin theta square. So when we square it, like this is in the form A plus B whole square. So it is A square plus B square plus A square plus B square cos square theta plus 2AB cos theta, and here it is B square sin square theta. So you will find B square is common in two terms. So B square we take it common and it is cos square theta plus sin square theta. And cos square theta plus sin square theta is 1. So it is A square plus B square plus 2AB cos theta. This cos square theta plus sin square theta in bracket, this gives you the value of 1 here. So we have the final relation for R square, that is resultant square. OS square is actually R square. So R square is A square plus B square plus 2AB cos theta. So the value of R will be given by root over A square plus B square plus 2AB cos theta. This is the exactly same relation which we obtained in the analytical treatment in triangle law of vector addition. So you should understand that whether we are using the triangle law of vector addition or the parallelogram law of vector addition, the resultant magnitude of the resultant will be given by the same formula, that is root over A square plus B square plus 2AB cos theta. And this is very, very important formula because all the time it will be used in higher studies also. So you need to understand and remember that very properly. Now we will discuss the direction of the resultant vector. Now to understand that or to find the direction of the resultant vector, we will say that it makes an angle of beta with the vector A. So in terms of vector A, we will give the direction of vector R, which is the resultant vector, and which will be given by beta. So we'll consider the right angle triangle ONS again. ONS is the right angle triangle here. So tangent beta will be given by Sn by On, where On is OP plus Pn, and the value of Sn is written as B sin theta. Then OP is A and Pn we have already discussed it, it is B cos theta. So tangent beta will be given by B sin theta by A plus B cos theta. And I hope that this is very clear to you. So the value of beta can be given by tangent inverse B sin theta by A plus B cos theta. Always remember one thing. In terms of vector A, we are finding the value of the angle which the resultant makes with the vector A. So when we start with tangent beta, this B is the opposite side to that of the angle here beta. So tangent beta will be given by B sin theta divided by A plus B cos theta. So I hope that up to this it is very clear to you. Now let us discuss some spatial cases, in which in these spatial cases we will be discussing how the resultant can be calculated when the two vectors, vector A and vector B, are making different angles. The first condition is if the two vectors, that is vector A and vector B, are acting along the same direction, that is theta is 0 degree, therefore the magnitude of the resultant will be given by, the resultant, the formula is root over A square plus B square plus 2AB, cos 0 is 1. So it is root over A square plus B square plus 2AB, which is written as root over A plus B whole square. So square root and square term will cancel out. So we have R, that is the value of the resultant or the magnitude of the resultant, is given by A plus B. Let me give you an example here. It will be very clear to you. Suppose I take this pen, and in this pen, if I let me enlarge the screen here so that you can see me properly. Suppose I take this pen, and in this pen, if I apply force, say 5 Newton in this direction and 3 Newton in the same direction, the two of the vectors of force are acting along the same direction, so the angle between them is 0 degree. So if it is 0 degree, naturally the resultant force acting on it will be given by 5 plus 3, which is 8 Newton. And in which direction? The resultant will be in the direction of vector A and vector B. Both are acting in the same direction, so resultant will also be in the same direction. So the resultant force will be given by first force plus the second force. As we have seen here, the resultant R is given by A plus B if both are acting in the same direction. Angle between them is 0 degree. I hope this is clear. Now let us see the special case 2. Here you can see in this part, when the two vectors are acting in the same direction, the magnitude of the resultant vector is equal to the sum of the magnitude of the two vectors acting along the same direction, and the resultant also acts along the same direction. Now let us see the second case, in which the two vectors are acting in the opposite direction, so the angle between them is 180 degree. So the resultant will be root over a square plus b square plus 2ab cos 180, and cos 180 is minus 1. So it is root over a square plus b square minus 2ab can be written as a minus b, or it can be written as b minus a also, depending on which one is greater. If a is greater, so we will write a minus b. If b is greater, then we will write b minus a. So the resultant will be given by the subtraction of the two magnitudes of vector A and vector B. That is, what we can say here is resultant is equal to the positive difference B minus A or A minus B, whatever we say, but we have to consider the first term to be higher value than the second term. So the resultant is equal to the positive difference between the magnitudes of the two vectors and acts along the direction of the bigger vector. Let me give you an example so that it becomes again very clear to you. Suppose this pen, now 5 Newton force is acting in this direction and 3 Newton is acting in the opposite direction. So two vectors are there acting in the opposite direction. The angle between them is 180 degree. Now in which direction the pen will move, and what will be the resultant force? 5, because it is the bigger one, minus 3. So it is 2 Newton, and the resultant will be in this direction. So the pen will move in the direction of higher magnitude vector. Is it clear? I suppose it is clear, but still, and if there is any doubt, you can post me the doubts. Now we will discuss the third condition, where the angle between the two vectors is 90 degree. If the angle is 90 degrees, so cos 90 is 0. So the resultant will be root over a square plus b square. Okay, and the direction of the resultant will be given by tangent beta, if we write, which is the beta is the angle which the vector, that is the resultant vector, makes with the vector A. So it is b sin 90 by a plus b cos 90. Cos 90 is 0 and sin 90 is 1, so it is b upon a. So the magnitude or the value of the angle which the resultant makes with the vector A is given by tan inverse b by a. So I hope this whole thing is very clear to you. If there is any doubt, then you can post me the doubt so that it can be cleared. Thank you and have